friends, in part 1 last video we have already discussed 11 points of this chapter, and these 11 points are very important for solving example of this chapter. We have already completed exercise 2.1. Now we are going to start exercise number 2.2 in this part 2. Exercise number 2.2, example number 1. Find zeros of the following polynomial and verify the relationship between zeros and coefficient. You already know the relationship between zeros and coefficient. For quadratic polynomial, alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Here in this exercise, we are going to solve some examples. First example, x square minus 2x minus 8. Here there are two questions. First one, find zeros, and second one, you have to verify the relationship. X square minus 2x minus 8 is equal to 0 because we want to identify the zeros of this polynomial. Here you can use method of factorization, which you have studied in standard 8 as well as in standard 9. So this is method of trinomial. So you have to factorize 8. Minus minus is equal to minus plus. So subtraction should be minus 2. So you have to split minus 2x in two parts such that minus 4x plus 2x it become minus 2x. So x square minus 4x plus 2x minus 8 is equal to 0. Now you can use common factor method. X common, you get x minus 4 plus 2, again you get x minus 4 is equal to 0. So here you get x minus 4 is equal to 0, therefore x is equal to 4. And x plus 2 is equal to 0, therefore x is equal to minus 2. So 4 and minus 2 are zeros of this polynomial, and these zeros are denoted by alpha and beta. Therefore alpha is equal to 4 and beta is equal to minus 2. So we have completed first part. Now the second part is you have to verify the relationship. Come on, you know alpha plus beta is equal to, alpha means 4, beta means minus 2. So 4 plus minus 2, it become 4 minus 2. So your answer is 2. Now alpha into beta, alpha means 4, beta means minus 2. So it gives us alpha into beta is equal to minus 8. Now let us verify this. You know alpha plus beta, the formula is minus b by a. From this polynomial you can easily find out a, b and c. So a means coefficient of x square is equal to 1, b means coefficient of x, that is minus 2, and c means constant coefficient, that is minus 8. Now put the value. So alpha plus beta is equal to minus b by a is equal to minus b means minus 2 and a means 1. So you get plus 2. Similarly, alpha into beta is equal to c by a. Value of c is equal to minus 8. A is equal to 1, and that's why alpha into beta is equal to minus 1. So here also alpha plus beta is equal to 2. Here also we get 2. Alpha into beta is equal to minus 8. According to formula is also alpha into beta is equal to minus 8, and that's how we verify. So this is the end of first example. Let me start example number 2. The example is 4x square minus 4s plus 1. Here s is used as a variable. So coefficient of x square is 4 means A is equal to 4. Coefficient of S is minus 4. So B is equal to minus 4 and constant coefficient is 1. So A is equal to 4, B is equal to minus 4 and C is equal to 1. Now 4s square minus 4s plus 1 is equal to 0. Again you have to use method of factorization. But here you have to factorize 4 ones are 4 in two parts. You need minus 4s. So 2 2s are 4. Minus plus is equal to minus minus. So in place of minus 4s, write down minus 2s and minus 2s. So your factor become 4s square minus 2s minus 2s plus 1 is equal to 0. Now use common factor method. Here you can take 2s common, you get 2s minus 1, you get minus 1 common, so in bracket you get 2s minus 1. So 2s minus 1 is equal to 0. Again 2s minus 1 is equal to 0. So when you find out the value of s, so s become 1 by 2. Here also s become 1 by 2. But the value of variable s is nothing but is your zeros, and that is known as alpha and beta. So in this example, alpha is also 1 by 2 and beta is also 1 by 2. Now alpha plus beta is equal to 1 by 2 plus 1 by 2 is equal to 1. Alpha into beta is equal to 1 by 2 into 1 by 2 is equal to multiplication of numerator, multiplication of denominator. So you get 1 by 4. Now your question is to verify this relationship with the help of formulae. So alpha plus beta is equal to minus b by a. So minus b means minus 4 upon a means 4. So 4 upon 4 is equal to 1, which verifies. Now alpha into beta is equal to c by a. C means 1, a means 4. So alpha into beta is equal to 1 by 4. Here also alpha into beta is equal to 1 by 4. So it verifies. So I have completed second example also. Well, so let me start third example. The third example is 6x square minus 3 minus 7x. You know, the three terms are not arranged properly. So first of all, you have to arrange these three terms. So the first term is 6x square, second term will be minus 7x and third will be minus 3. To find 0, you have to equate them is equal to 0. Now again you have to use method of factorization, trinomial. 6 3s are 18, so you have to factorize 18 in different two parts. How to identify these two parts? So middle term should be minus 7. So you can factorize 9 2s are 18. Minus minus is equal to minus plus. So minus 9 plus 2 becomes 2 factor of 18. So in place of minus 7x, write down minus 9x and plus 2x. So 6x square minus 9x plus 2x minus 3 is equal to 0. Take 3x common, you get 2x minus 3 plus 1 common, 2x minus 3 is equal to 0. So you get 2x minus 3 is equal to 0 and 3x plus 1 is equal to 0. So here you can easily find out the value of x. So x is equal to 3 by 2 and here x is equal to minus 1 by 3. Now you know alpha is equal to 3 by 2 and beta is equal to 1 by 3. And alpha is equal to 3 by 2, beta is equal to minus 1 by 3. You can also easily find out the value of a, b, c. So a is equal to 6, b is equal to minus 7 and c is equal to minus 3. So I have already find out value of alpha and beta. I have already find out the value of a, b, c. Now you have to just verify the relationship between zeros and coefficient. Means here you have to find out alpha plus beta, then alpha into beta with the help of alpha is equal to 3 by 2 and beta is equal to minus 1 by 3. And then you have to find out the value of alpha and beta with the help of formula. Alpha plus beta is equal to minus b by a. Alpha into beta is equal to c by a. You can solve this example. Now let me start example number 4. You know, in this example you have to find out zeros and then you have to find out the verify. find out and verify the relationship between zeros and coefficient. Now let me start fourth example. The fourth example, here variable is equal to u. So pu is equal to 4u square plus 8u. The first question is to find out the zeros. So 4u square plus 8u is equal to 0. You can take 4u common. So u plus 2 is equal to 0. Because when you take 4u common, the remaining term is u. Here when you take 4u common, you get 2. So from this we can write 4u is equal to 0 and u plus 2 is equal to 0. So u is equal to 0 and u is equal to minus 2. So alpha is equal to 0 and beta is equal to minus 2. So this is the way to find out the zeros of the polynomial. Now your aim is to verify this. So let me find out alpha plus beta. So alpha is equal to 0, beta is equal to minus 2. So it gives you minus 2. So alpha into beta is equal to alpha means 0 into minus 2. It becomes 0. Now our question is to verify them. So alpha plus beta is equal, according to formula, it is minus b by a. So first of all, let me find out the b and a. So a means 4, b means 8, and constant coefficient is not given in this polynomial, and that's why it is 0. So minus b by a. So minus b means 8 by a means 4. Again you get minus 2. It verify with alpha plus beta. Now alpha into beta is equal to c by a. Here c means 0, a means 4, 0 by 4 is equal to 0. So we have verified this. Now let me start example number 15. Example number 5. T square minus 15. So t square minus 15 is equal to 0. In the example number 4, your variable is u, while in example number 5, your variable is t. Now to find out 0, first of all, you have to equate them equal to 0. So t square minus 15 is equal to 0. Here you have to use one special method of 8 standard of factorization, and that is difference of 2 square. So t square minus 15. So 15 you can write under root 15 whole square is equal to 0. Now you know a square minus b square is equal to 0. Its factor is a minus b and a plus b. A square minus b square is equal to 0. Therefore a minus b, a plus b is equal to 0. So t is equal to under root 15 and t is equal to minus under root 15. So your alpha is equal to under root 15 and beta is equal to minus under root 15. So here we have already find out the value of alpha and beta, that is zeros of this polynomial. Now question is to find out and verify the relationship. Come on. So alpha plus beta is equal to under root 15 plus minus under root 15 is equal to 0. Alpha into beta is equal to under root 15 into minus under root 15 is equal to minus 15. Now let us verify this with the help of formula. Alpha plus beta is equal to minus b by a. Let me find out a, b and c. Here a means 1, b means 0 and c means constant coefficient, that is minus 15. So alpha plus beta is equal to minus b by a. So minus 0 by 1 is equal to 0. It verify with alpha plus beta. Now alpha into beta is equal to c by a. C means minus 15 and a means 1. So your answer is minus 15. So it also verify with alpha into beta. Now let me start example number 6. 3x square minus x plus 4. You know here a is equal to 3, b is equal to minus 1 and c is equal to minus 4. Now let us solve this example. First of all, you have to use method of factorization and then find out the value of zeros. So 3x square minus x minus 4 is equal to 0. So 4 3s are 12. So here you have to factorize 12 into part. Minus minus is equal to minus plus and subtraction should be 1. So you can write 4 3s are 12. So in place of 3x square, in place of minus x, write down minus 4 plus 3x minus 4 is equal to 0. Here you can take x common, then you get 3x minus 4. Here you get plus 1 common, then 3x minus 4 is equal to 0. So 3x minus 4 is equal to 0. 3x plus 1 is equal to 0. So you can easily find out the value of x. So here x is equal to 4 by 3 and x is equal to minus 1 by 3. So your alpha is equal to 4 by 3 and beta is equal to minus 1 by 3. Sorry, here x plus 1 is equal to 0. So x is equal to minus 1. Here beta is equal to minus 1. Let me explain this again. 3x plus 4 is equal to 0 and x plus 1 is equal to 0. Therefore x is equal to 4 by 3 and x is equal to minus 1. Now alpha plus beta. Alpha plus beta means 4 by 3 plus minus 1 means minus 1 upon 1. You can take 3 as LCM. So you write 4 minus 3. So it become what? 1 by 3. These are alpha plus beta. Now alpha into beta is equal to 4 by 3 into minus 1 is equal to minus 4 by 3. Now verification of zeros and relationship. So alpha plus beta is equal to minus b by a. Your b is minus 1 and this minus 1. So minus 1 become plus 1 and a means 3. So your answer is 1 by 3 which verify with alpha plus beta. Now alpha into beta is equal to c by a. Your c is minus 4 and a means 3. So your answer is alpha into beta is equal to minus 4 by 3 which verifies with this. So we have completed exercise number 2.2 first question. There are 6 sub questions to find out zeros and verify the zeros and relationship between zeros and coefficients. So we have completed this 6 examples. We have completed question number 1 of exercise 2.2. Now let me start example number 2 of exercise number 2.2. You know, in first example of exercise 2.1, what is given to you? The polynomial, quadratic polynomial is given to you. And your question was to find out the zeros and then verify the relationship between zero and coefficient. But now in this example, just inverse process. What is given to you? The sum of the zeros and product of the zeros are given to you. And your aim is to find out quadratic polynomial. Let me read this example. Find quadratic polynomial, each with the given numbers as the sum and product of its zero respectively. So in this example, What is given to you? You have to given sum of the zeros and product of the zeros. And your aim is to find out quadratic polynomial. You know the general formula of quadratic polynomial is ax square plus bx plus c. So in this example, your aim is to find out the value of a, b, c. If you find out the value of a, b, c and put the value of a, b, c in a general formula of quadratic polynomial, that is ax square plus bx plus c, you will easily find out the quadratic polynomial. So let me explain the procedure. How to find out a, b and c from alpha plus beta and alpha into beta. In this question number 2, 6 examples are given to you. I am going to solve first 3 examples, and on the basis of this you have to solve the example number 4, 5 and 6. Well, let me start example number 1. Here 1 by 4 and minus 1 is given to you. So 1 by 4 means alpha plus beta. So alpha plus beta is equal to 1 by 4. But you know the value of alpha plus beta is equal to minus b by a. Similarly, alpha into beta is equal to minus 1. But you can write minus 1 means minus 1 upon 1. And you know the formula, alpha into beta is equal to c by a. Now if you compare this ratio, here a is equal to 4, a is equal to 1. So you have to take highest multiple of a. And that's why you have to take a is equal to 4. So when you take a is equal to 4, minus b become 1. So b become minus 1. Now b become minus 1. Now c by a is equal to minus 1. C by a is equal to minus 1. The value of a is equal to 4. So c by 4 is equal to minus 1. Again we get c is equal to minus 4. Now you know the value of a, b and value of c. Now put the value of a, b and c in the formula, general formula of quadratic polynomial, that is ax square plus bx plus c. A means 4, b means minus 1 and c means minus 4. So 4x square minus x minus 4 is your quadratic polynomial. So the general formula of polynomial is 4x square minus x minus 4, where a is not equal to 0. Because this is to find out the general formula, you have to multiply your polynomial with k, where k is not equal to 0. So this is the procedure. How to find out quadratic polynomial? Means how to find out a, b and c from alpha plus beta and alpha into beta. Let me explain the another example. You know, alpha plus beta is equal to under root 2. So you can write under root 2 by 1. You know the formula, alpha plus beta is equal to minus b by 1. Now alpha into beta is equal to 1 by 2. You know the formula, alpha into beta is equal to c by 1. When you compare these two ratio, here a is equal to 1, here a is equal to 3. So you have to take highest multiple of a. So a is equal to 3. When you take a is equal to 3, your c become 1. Now write the value of a is equal to 3 here. So minus b by a is equal to root 2. In place of a, write down 3. So minus b is equal to 3 root 2. So b is equal to minus 3 root 2. So now you get value of a, b and c. Now put the value in general formula. So px is equal to ax square plus bx plus c. So a means 3x square, b means minus 3 root 2x plus c means 1. So general formula of polynomial is k times 3x square minus 3 root 2x plus 1, where k is not equal to 0. So in this example, alpha plus beta is given to you. Alpha and beta is given to you. Your aim is to find out ABC, and from the value of ABC, you can easily find out the quadratic polynomial. Let me explain that example. Here, alpha plus beta is equal to 0. So you can write 0 by 1. And you know alpha plus beta is equal to minus b by a. Similarly, alpha into beta is equal to under root 5. You can write under root 5 by 1. And you know the formula. Alpha into beta is equal to c by a. So when you compare these two ratios, here a is equal to 1. Here also a is equal to 1. So obviously, the highest number is a is equal to 1. When you take a is equal to 1, the c become under root 5. When you take a is equal to 1, minus b becomes 0. So b is also 0. So now you know the value of a, b and c. Now put the value of a, b and c in general formula. So what is your px? Ax square plus bx plus c. Put the value. A means 1, so 1x square means x square. B means 0, it becomes 0x. Plus c means under root 5. There is no need to write 0x because its value is 0. So the px is x square plus under root 5. So general formula of polynomial is k times x square plus under root 5, where k is not equal to 0. So sometime in board examination they ask one question on the basis of this formula, means alpha plus beta, and alpha into beta is given to you, and find out the quadratic polynomial. So the weightage of these example is 2 marks. I have already solved first 3 examples. You can easily solve the 4th, 5th and 6th. Let me give some clue how to solve this example. You know, alpha plus beta is equal to 1 and alpha into beta is equal to 1. So you know alpha plus beta is equal to 1 means you can say 1 by 1 is equal to b by a. Alpha into beta is also 1. So is equal to 1 by 1. So is equal to c by a. So b by a is equal to 1. C by a is equal to 1. So a is equal to 1. Here a is also 1, b is also 1 and c is also 1. Put the value of a, b and c, that is 1, 1 and 1 in general formula. Ax square plus bx plus c, you get x square plus x plus 1. So your quadratic polynomial is x square plus x plus 1. And you can easily write the general formula of polynomial is k times x square plus x plus 1. I have solved this example orally. Similarly, you can also solve this example number 5 and example number 6. In 5th one, alpha plus beta is equal to minus 1 by 4. Alpha into beta is equal to 1 by 4. So minus b by a is equal to minus 1 by 4. C by a is also 1 by 4. So you can say a is equal to 4. When you take a is equal to 4, c is equal to 1 and b is equal to minus 1. So put the value of a, b, c in general formula. You can easily solve this example. The 6th example is also very simple. You know, alpha plus beta is equal to 4. So you can write 4 by 1. So alpha plus beta is equal to minus b by a is equal to 4 by 1. Similarly, alpha into beta is equal to 1. So is equal to 1 by 1 is equal to c by a. So a is equal to 1 in first ratio. A is equal to 1 in second ratio. So you can take a is equal to 1. If you take a is equal to 1, c is equal to 1 and b is equal to 4. So b is equal to 4, c is equal to 1 and a is equal to 1. Put the value of a, b, c in general formula. You can solve easily the 6th example. So with this, we have completed exercise number 2.2. So in last 2 lectures, first we have completed 11 concepts. You know, without concept there is no importance. So we have completed 11 concepts of this chapter. Then we have start exercise number 2.1, that is find out the number of zeros from the graph. Then we have started exercise number 2.2. 2 examples are there. In first example, polynomial is given to you and you have to find out the zeros. While in second example, alpha plus beta and alpha into beta is given to you, and you have to find out the quadratic polynomial. Now, in exercise number 2.3, we are going to solve example on the basis of division algorithm. That is our concept number 11. You know, in concept number 11, we have write down one thing, that is fx is equal to gx into qx plus rx, means dividend is equal to divisor into quotient plus remainder. So how to divide one polynomial by another polynomial? That is exercise number 2.3. So in last and next lecture, we will solve some example how to divide a given polynomial by another polynomial. Thank you friends. Thank you.